just wanted to talk about resisted forces when something is in motion. Now, a resisted force is a force that acts against the direction of the object. So it's in the opposite direction. So if you look at this one up above in the horizontal plane, if the direction was to the right, the resisted force would be going to the left. It could be like on this here, it could be something as simple as friction, because friction will act against it and go in the opposite direction to slow the motion down. Okay, so the direction of the force, we always make that a positive, and the opposite direction, we'll make that a negative. So if you're looking at the sum of the forces here, the sum of the forces here would just be your resistance force, which will actually be negative because it's acting in the negative direction. And the sum of the forces is just mass times the acceleration. So the acceleration would just be equal to whatever the resistant force is. Okay, so let's just look at a question. So first of all, a particle of mass 6 kilograms is projected horizontally along a plane to the right with initial velocity of 40 meters per second and a resisted force of 30 v meters per second squared. Okay, so we've got a few questions to find here. So we've got to show that acceleration is minus 5v. So first of all, let's have a look at this. So we've got our particle, it's moving to the right, that's its direction. It has a resistant force in the opposite direction, and the resistant force is minus 30v. Okay, so the sum of all the forces would be minus 30v. Like you have a weight force going down, but that's actually not going to affect the horizontal motion. And then mass times the acceleration is equal to minus 30v. The mass is 6, so 6 times the acceleration is minus 30v. So therefore the acceleration, if you divide by 6, 30 divided by 6 is 5. Okay, so that's the acceleration equals minus 5v. Okay, part B. Show that v equals 40 minus 5x. So we start with our acceleration equals minus 5v. And then we just go dv on dx equals minus 5v. The v will cancel out. So that means you've got 1 dv equals minus 5 dx when you split the derivative. And then you integrate both sections. So you get v equals minus 5x plus c. Now, initially, x will be 0. Okay. And the starting velocity, if we go back up to the question, the starting velocity is 40 meters per second. So you've got time is 0, x is 0, because it's where it has to start at some point, and v is 40 meters per second, so it's travelling to the right. So x is 0, v is 40, let's put that in. So 40 is minus 5 times 0 plus c. So c will equal 40, so that means that v equals minus 5x plus 40. So v equals 40 minus 5x as required. Okay. All right, so show that v equals 40e to the minus 5t. v equals 40e to the minus 5t. So that's the prize we're after. We'll start with our acceleration. Now we want to get our velocity in terms of t. So that requires replacing the acceleration with dv on dt equals 5b. Group the v's together. So you got 1 on v dv equals 5 dt. And simply integrate both sides. So that it will be ln of v, and that's 5t plus c. So then when time equals 0, v is equal to 40. Time equals 0, v is 40. So it's ln 40 is 5 times 0 plus 5, 0 is 0 equals c. So ln 40 is 40. Okay, so that means that ln v equals 5t plus ln 40. Bring the 40 across. there you go, ln v minus ln 40 equals 5t, because you've got to group the log parts together. So that's ln v on 40 equals 5t. All right, now remove the e. So you go e to the power. That's e to the power of 5t will equal v on 40. Now I'm just going to check the sign of that. I've dropped the negative. I just realised that. I'll just put the negative back through. So it's to the power of minus 5t equals e to the minus 5t. V equals 40, e to the minus 5t. You could put plus or minus 40, but it is moving to the right, and the initial condition is a positive, so it's got to satisfy those initial conditions. So v equals 40, e to the minus 5t. So we've got the acceleration is minus 5v. We've done this one. We've shown that v equals 40 minus 5t. V equals 40, e to the minus 5t. And now we need to show this here. Now, to get the displacement, that's a, b, c, d, we could get it using the things that we've just found. Like we just know 40, v equals 40 minus 5x, and we also know v equals 8, so 40 minus e to the minus 5t. So because these are both v's, if we make them both equal to each other, then we have a way then. So we go 40 minus 5x equals 40 minus e to the minus 5t. Oh no, it's not 40 e to the, it's times 40 e to the minus 5t. Okay, so looking at that then, if I bring the 5t over there and I bring this one over here, then we get 40 minus 40 e to the minus 5t equals 5x. And then if I divide by 5, I'll end up with my 8 minus 8e to the minus 5t equals x. Okay? All right, so what is the limiting displacement? So as time goes to infinity, that will give me the limiting displacement. It's 8, and this is 1 over e to the 5t. So this here, the bottom will get big, so the whole thing will approach 0. So it's 8 minus 8 times 0 is 0, so x will just approach 8 meters. So the limiting distance is 8 meters. Now this last part here, find b. Use b to find x in terms of t. Now b was just this one, v equals 40 minus 5x. So if I want to get x in terms of t, like I did before, but I want to use this, you're going to have to change that to dx on dt, because you want to get it in terms of x and t. Move this down here, so that would be 1 over 40 minus 5x dx equals 1 dt, and then from there that's minus 1 on 5 ln 40 minus 5x equals t plus c. Okay, so we also know time equals 0, x equals 0, so minus, I've got to find the c, so it's 40 minus 0 equals 0 plus c. So c is minus 1 on 5 ln 40. So now if we plug that back in, you got minus 1/5 ln 40 minus 5x will equal t, and it'll t 1 on 5 ln 40. So if you bring that over, that's 1 on 5 ln 40 minus 1 on 5 ln 40 minus 5x equals t. So if I times everything by 5, the 5 will go. So you get ln 40 minus ln 40 minus 5x equals 5t. Now I'm going to swap the signs around here and make that positive 40 minus 5x minus ln 40 equals minus 5t. And I can simply do that because all I've got to do is, if I times both sides by -1, then it just changes the sign of everything. And this comes to the top because it's now positive, and that one will make it there because it's negative. And that allows me to group the logs together so that the x is actually on top, which makes it a little bit nicer. So this is log base e. So I'm just going to rearrange it with using the log rule. So e to the -5 on t equals the 40 minus 5x on 40. So that's e to the -5t. And then minus 5x with a 40 there equals 40 e to the -5t. Minus 5x equals 40 e to the -5t minus 40. You can see it's looking very close to what we got before over here. Divide by -5. So you get 40 on -5 e to the -5t minus 40 on -5. So it's -8 e to the -5t plus 8. Or 8 minus 8 e to the -5t. And therefore that is now done, which is the same thing.